Okay, so last couple days, if you've been absent from class, we've talked about rational functions and slant asymptotes. And a slant asymptote is an asymptote that is at an angle through the graph, and the graph might get closer and closer to it as it cruises left to right. Okay, so what we're going to do here, I want to get this off of the screen here because that may not be accurate to this problem, but we're going to find that slant asymptote. And the first thing to realize is that slant asymptotes only happen when it's top-heavy, when the rational function is top-heavy. What does that mean again? When the degree of the top polynomial is more than the degree of the bottom polynomial. And so how do you find slant asymptotes? You do long division. So we're going to put x minus 1 out in front, 3x squared plus 2x minus 6 inside. What do I take times x to get 3x squared? 3x. 3x times x is 3x squared. 3x times 1 is a negative 3x. We will simply change the signs. Add down. 5x. Bring the next term down. And ask yourself again, what do you take times x to get 5x? That would be 5. 5 times x is 5x. 5 times negative 1 is negative 5. Change the signs. Add down. Negative 1. Oops, negative 1. And so we don't really care about the remainder too much on these, but the slant asymptote is this value at the top. So when you're done, you have y equals 3x plus 5. And now if you wanted to, you could put this original function in y1. You could put this guy in y2 of your calculator, and you could actually see that graph get closer to it. It just kind of crawls up against that line there. So that's how you find slant asymptotes. It's pretty easy if you already know how to do long division. And let me know if you have any trouble.